Hi guys, so today we will start with the new question number 3 from group A, which is to write a Python program for the department library, which has n books. Write functions for the following. First of all, delete the duplicate entries. Second, display books in ascending order based on the cost of books. Third, count number of books with cost more than 500. And fourth, copy books in a new list which has cost less than 500. So we have to perform these four operations. Let's just copy this question and head on to our text editor. Let's just paste this thing and save this file as question3.py. So let's just save this thing, comment all of this stuff, and let's just think how we can solve this question. So as per the question, we would be given some set of data. So as we know, whenever we have a collection of data, we use a data structure called as list to store all of these elements. So similarly here also, we will create a book list and we will store all of the books. So let's just name it B1, B2, B3 and so on. So we would have the list. So now as per the question, the books would also have a cost. So depending on cost, we have to perform some operations. So book would also have a cost, and for our convenience, let's just give this a name also. So because there may be some elements of same cost but different names, so to differentiate them, we can use a name and a cost. So for creating such a thing, we can use a concept called as classes and objects. So we can create a class book and then store the reference of all this name, cost and various things, and then use this. But let's just assume we don't have any idea about this class thing or the object-oriented programming. So we are a newbie. So what we can do is we can store this collection of data, or we can group this data into a thing, or into a data structure called as tuple. So we can use a tuple which is indicated by the parenthesis, and we can use the name. So we can use the name and cost and store this in a tuple. So basically grouping them, and we could state this thing as a book. So a book would be a tuple in which the first element would be the name and second element would be the cost. So like this we can store each reference of this book. So B1 would be a separate book, B2, then B3 and similarly so on. So let's just create this thing. So let's just create a book list. So it would be an empty list in which we can add then books. So let's just create a function to add these books to. So add book, and it would take a name and cost, and depending on this will add books to the list. So book list dot append, and we would append a tuple, or we would append a book. So let's just create this book equal to a tuple of name comma cost. So tuple is indicated by this parenthesis. So this is same as the list. We can index these elements using the square brackets and the index number. Similarly, but for now we would create a book book tuple of book. So then what we can do is let's just add some books. So add underscore book, and the name would be DSA, and then the cost would be 500. Then let's just copy these things again and create some more books, and DSA same. So we will create a duplicate of this DSA book. So let's just print the book list and check whether this function works fine or not. So here we can see the function is working fine. So 1 2 3 4 5 6 elements are added, and we can see the 6 elements. So now we have created a list of n books. Now we have to perform this thing, delete the duplicate entries. So for this we have to create a function. Let's just define a function delete underscore duplicate, and it would take a list. So let's just take book list, and let's just pass for now and think for the approach. So let's just save this thing. So now we have to think how we can remove this duplicate elements. So let's just take some simple elements: 1, 2, 3, 2, 4 and 3. So these would be the, let's just assume these are the book numbers, and we have to now create a list or delete the duplicate entries. So we have to delete this duplicate entries. What we can do is we can create an empty list. So let's just create an empty list. Then we will loop through these elements of the main list. So first of all, we will go to 1. We will check whether this element is present in this list or not. So it is not present, we will add 1. We will check for second element, it is not present, we will add it. We will check for third element, it is not present, we will add. Then now when we are checking for 2, if 2 is present in this list or not. So it is present, so we will not add that. So we will not add this 2. Similarly, again we will check for 4. So 4 is not present, so we will add that. Again we will check for 3. 3 is present, we will not add that, so we will discard that. So like this we can create a list which would delete the duplicates. So here in this new list, no duplicates are there, so each individual unique elements are there. So let's just code this thing. So what we have to do is we have to first of all create a list. So unique underscore list, or unique books, or unique list would be fine. Let's just create an empty, and then what we can do is for book in book list. So book underscore list. So for book underscore list, we will be getting each book. So first of all, DSA 500, we will get this tuple. So as we are considering this tuple as a book, so we will get this thing. So we will check if book in book list, not the book list, the unique list. So unique list. So if this book is in the unique list, we will not add, but if it is not present, then we will add. So we have to inverse this thing, because if it is present, it will return true, and if it is not present, then it will return false. So when it will return false, then we have to execute something. So instead of using an if else condition, we can directly negate this value. So we can take the inverse of this by adding a not. So whenever this thing returns true, the not would inverse that value and it will create that false. And similarly, if this returns false, means the book is not present, so we will use this if condition as true. So now if it is not present, if not book in unique list or book not in, so both would work fine. So let's just modify this thing to not in. So book not in unique list, what we will do, if it is not present, then we will add. So unique underscore list dot append the book. So let's just change this name to unique book list. So book underscore list. So now this should work fine. Let's just execute, and at last we will return this thing. Return unique book list. So let's just call this function. So book underscore list equal to the delete underscore duplicate, or we can copy this name and use the book list. So we can either do this, or what we can do is directly assign book list as unique book list. So instead of that, this should be fine. So let's just print the book list. Print book underscore list, and now we can see the duplicate element is removed. So let's just copy some of the elements. So let's just take this set of books and again add this and execute. So at first there were these many elements, but after that we have removed the duplicates and created a new unique list. So now book list is unique. So the first function delete duplicate is working. Now for the second thing, we have to display book in ascending order on the basis of cost. So first of all, let's just see how we can arrange this book in ascending order. Then depending on the cost, we will do the thing. So let's just take some random numbers. So 2, 5, 3, 7, 1 and 4. So let's just take these numbers, and this would be our books or the cost of the books. So now we have to arrange this in ascending order. So the basic ascending order would be 1, then 2, then 3, then 4, 5, 4, 5 and 7. So this would be the basic ascending order. So now we have to convert this element into this thing. So what we can do, so whenever I would have this list, what I can do is I can search for I can look through each of the element. So I will look through 2, 5, 3, 7, 1, 4, and I will find out the minimum value. So here the minimum would be 1. So what I can do is I can take this 1 and transfer it to the first position. Then now my list would be something like, let's just see how the list would be there. So my list would be 1, and what we will do, we will swap this thing to again this position, or we can keep there only, but as we are removing this element, so here there will be an empty spot. So what we can do is we can take the first element and put it there. So basically we are swapping. So we will put 1 here, and 5, 3, 7, 2, 2, 4. So here we have basically swapped. So now this much part is in ascending order, we can say. So if we create a line here, so this much part is in ascending order. So here now I will perform the same thing. I will check for 5, 3, 7, 2, 4, which would be the minimum. I will swap this with the next element. So 5 will come here and 2 will come here. So then my list become 1, 2, 3, 7, 5, 4. So similarly this much part is now in ascending order, proper ascending order. So then what I can do is I can again do the same thing on this 3, 7, 5, 4. So here 3 is minimum, so it is at right place. Similarly for next element I will again check for 7, 5, 4. So 4 is the minimum, so I will swap this element. So 7 and 4 will be swapped. So now 4, 5 and 7. So now I can see the whole list is now in the ascending order. So 1, 2, 3, 4, 5, 6, 7, the thing we required. So here what we are basically doing, we are looping through each element. So we are going through each element and checking which one is the minimum, storing that and swapping it with the current index. So if I am at the 0th index, I am swapping it with that. Then I will go one index ahead. I will check for 5, then for 3, then for 7, then for 1 and then for 4. So similarly I will go on doing this. So let's just do this. So let's just try to implement this. So let's just create a function. So define arrange books. So arrange books would take one book list, and then let's just use the for loop. So for I in book list, so here we are getting each book in this I. So instead of I we can use the book. So now here I am getting each book of this book list in the variable called as book. So what I can do is then I can again check for the all of the elements, and if it is minimum then I can use this. So instead of using this book, instead of using this for loop, we can use a for loop on the indexes. So for I, so let's just use I in range and length of book list. So why I am using this index instead of directly using the books? So I have to keep track where to swap the books. So I have to check which element is not yet in the ascending order. So if it is not in ascending order, then I have to swap and do the further thing. So for that I can directly use a for loop. So now currently I can take the min value. So what I can do is I can take the min value as book list of 0. So the first element of 1. So here this would confuse you. What we can do is we can directly take, or let's just create one simple list which would have the numbers. So this is our basic list which we just took as an example. So this would be our book list. So what we can do is minimum value. Let's just at first consider the minimum value is of book underscore list of 0. So we'll get this list as an input, and the 0th element of that element, let's just consider it as min value. So the minimum value. So what we will do in the loop, so we'll check if min underscore value is greater than the book underscore list of I. So means basically we are performing the same loop of checking the minimum value. So for each loop we are checking if the current min value we have set is greater than the current index element. So we are going through index. So if it is greater than, we will change. Why? Because we have to find the minimum value. So if min value contains bigger value than the element in the list, then we will update this min value. So min underscore value equal to book list, book underscore list of I. So now what will this do? Let's just see. Let's just print this min underscore value, and let's just comment this stuff out. So we can directly comment this thing and execute. So now we can see, okay, print min value. Okay, we have not called the function, so it hasn't called. Let's just copy, paste, and we will use the BL list. So here the minimum value in this list is 1. So first of all, we are printing the minimum value. So what we have to do now is swap these two things. So let's just create a swap function. So swap, we can directly use the tuple unboxing to swap the things. So what I can do is I can use this minimum value and I have to swap the thing. So swap, instead of swap, what I can do is a of 0. So currently I have taken the 0th index, so I have 0, and then I have to swap with the ith index. So instead of storing the value, what we can do is we can store the index, because we are working with the index. So a of 0 comma I equal to a of I comma a of 0. So what we are basically doing is swapping the things. So a of 0 would get the value of a of I, and a of I would get the value of a of 0. So we'll print the BL list first. BL, we will print the index. Let's just print, so print min underscore value means we will get the min index, and after getting the minimum index we'll again print at last. So print the BL means the book list, modified book list. So if we execute, so there is some error, a is not defined. So instead of a, we have to use the book list, book underscore list, and this should work fine. So now first the list was 2 5 3 7 1 4. After that, what have we done? We have used the index 4. So index 4 is 1. So let me just check. Okay, so here now 2 is at the first, 2 5 3 7 1 4, then the index is 4. So 0 1 2 3 and 4. So currently the index is 4, which is 1, and then we have swapped. Okay, so here is an issue that instead of I, we have to use here the min value. because we are swapping with the minimum value. So this contains the index where the minimum value is present. So now if we execute, here we can see 1 and 2 got swapped. So here we have swapped the 1 and 2, and now until here the first element, this is arranged in the ascending order. So now what we have to do, we have to do the same process for this list, and again for this list, again for this list, again for this list. So basically I have to use an counter and go on incrementing the I value. So what I can do is I can use a for loop. So for j in range, so the range would be the length of book list. So length of book list, and then we can use a indentation, and instead of using this 0th element we will use the jth element. So wherever we have used the 0 we will use j. So why are we using j? Because, so first of all we have considered that 0th element is to be sorted. So at the 0th element we have to get the minimum element. Then the for loop executed for checking the minimum element, and we swap the value. After swapping we will now increment the j. So j will become 1. So then we will check for 1 to the length, then again j will increment, and 2 to the length, then 3 to the length, and 4 to the length. So here we have to change, we have to start from the j, not from the I. So basically whenever we not provide any starting value, it will defaultly choose 0, but we have to start from the jth index. So now this should work fine. Let's just see list out of index. So what we can do is, so here we are getting an list index out of range error. So what is happening here? Let's just try to debug. So here j is inside the length and I is also inside the length. So we are starting from j up to the length. So this is correct. So let's just try to print the j and I for each case. So here we can see the minimum value is the index. So we were considering this min value as an index, and we are printing this min value for each loop. So here we can see 4 is fine, 2 is fine, 4 is fine, but at last here we can see a 7. So there can't be any index 7. Why? Because the list is of 6 elements. So 6 elements means the last element is 5. So let me just explain this. So we have the elements 2, 5, 3, 7, 1, 4. So these are the elements we are having in the list. So what is happening here? If we just put the index, so 0, 1, 2, 3, 4, 5. So here are 5 index, but the mean value which is considering the index is having 7 index. So it is not possible that list would have the 7th index. So there is some issue with this code. So if we check here, so here we can see min value, we are considering this as an index, but here book list of j is added, means the value is added. So here book list of j means 7, means 2, 5, 3 and 7 is added, but we have to only add the index. So we can use j instead of the min value. Similarly here we are directly checking with the min value. So instead of checking with the min value, it is an index. So we have to use the book list, and then this should work fine. Now we can see 1, 2, 3, 4, 5, 7. So let's just remove this print statement, and I will try to explain this again. What we can do, yeah. So what is happening here for j in range book of list? So we are looping through 2, 5, 3, 7, 1 and 4. So what we are doing, first of all, when we are at the 2, we are setting this element or this index as the minimum value. So we are setting this index as a min value index. So let's just change this name. So min value underscore index. So okay, we will just revert the changes so it looks nice here only. So here what we can do is, so what we are doing is we are considering this index as the element is having the minimum index. So here we are looping on each of the elements of this list and going to each element such as 2, 5, 3, 7, 1, 4. So here at first we are going to 0th index, which is having the value 2, and what we are considering mean value index, means currently we are assuming that the mean value is 2. So we are assuming mean value is 2 and then setting that index position j to the mean value, and then we are looping through the element from j to the length of the list, means we are starting from j to the length of the list. So we are going through each of the elements and checking which element is having the minimum value. So here 2 is having, 5 is having, 2 is the minimum, 5 is not minimum, 3 is not minimum, 7 is not minimum, 1 is the minimum. So here we received 1 in the minimum value index. Then what we are doing, we are just swapping. So we are swapping 1 and 2. So let's just print this thing in each level. So let's just print the book list. So if we execute here, you can see 2 and 1 got swapped. So 2 and 1 got swapped. For the next thing, what we are doing, we are checking for from the 5 because j is incremented. So after j is incremented, we are checking for the minimum element in this selected region. So here the minimum is 2. So 2 and 5 got swapped. So here we can see 2 and 5 got swapped in the next element. Then we are checking for 3 and we are checking in this list whether there is any minimum element. So 3 is the minimum element. So it's got swapped with this. So 3 got swapped with its own index value. Then for the 7, 5, 4, we again checked for the same thing. 4 got swapped with the 7 because 4 is the minimum value. Then 5 and 7 are the same. Again 5 and 7. Why? Because this is acting for 5 and 7. And again 7 is checking for the next further elements. And this goes on. So here we can see at last there is 3 times printing. So let's just check this out. So here while we were discussing the last thing, we came up to 1, 2, 3, 4, 5, 7. Okay. So what happened? 7 and 4 got swapped. And then this list becomes sorted. As we can see all of the elements at one go, we can say that list is sorted, but computer doesn't know when to stop. So what we are going, we are again checking for 5, we are checking with the 5 and 7, and we are swapping, again checking for 7 and again for the next element and checking whether any minimum element is present or not. If present, then we are doing the same thing. But here this 7th check is not necessary. Why? Because after 7 there is no element present. So what can we do? We can only check up to 5. So we can modify the thing. So we can modify this length up to length -1, because in the last check what we are going to do, we are going to check whether 7 is minimum or not. But indirectly we know as all of the elements before 7 is sorted, then 7 is automatically sorted. So let's just execute this again, and here we can see 4 and 7 got swapped. Then for 5 and 7 it checked and it stopped. So similarly, if we take one more element, so let's just take 8. So here we can see, so 8 was already sorted. So let's just take somewhere here. So 8 comma and this thing. So let's just execute this. So here 5 and 7 got swapped in this position. Then it checked for 7 and 8, and after checking for 7 and 8, both of the values were same, means they were in correct order. So it didn't swapped in the last case. So we are avoiding one check, but we can see here 3 of these are possible. Similarly, if we take some element another than 8 here, so here we can see at last we are swapping the element. So now we can see this list is now arranged according to the cost. If we consider these numbers as a cost, this is arranged correctly. But now we are not going to get this integer array. We are going to get an array of book which would contain a tuple. So here instead of this index would be correct. So there is no issue with this index. This I range also would be correct. There will be only change in the book list mean value. So book list mean value would return a tuple. So what we can do is, let's just comment this out. Let's just remove this print, and here let's just directly print the book list. So book underscore list of min underscore value underscore index. So if we try to execute this, so there is an issue, BL not defined. Okay, you have to not provide BL, book underscore list. So it didn't print anything, so we have to use the print statement. So if I execute this, now we can see, okay, it is printing again and again. What we can do is we can print and break. So we can directly break, and here we can see each book is getting printed. So here in this book list min value index, we are getting a book, not the single integer value. So what we can do is we can index this, and we can take the first element of this thing. So the 0th element is the name, and first element is the cost. So here we have to arrange these books according to the cost value. So what we can do is we can use this cost value and then perform all this operation using this cost value. So simply we have to add the square bracket and 1 for each of the case. So what we can do is here we have to add square bracket and 1, means we are choosing the first element. Here we are also choosing the first element. The min value index would be the same, but here the book list j of 1. Why? Because we are choosing the cost. Here also we are swapping the cost. Okay, instead of here swapping the cost, we have to swap the whole book. So in the last case we are comparing the things. So while comparing, we have to compare using the cost of the book, but while swapping we have to swap the whole book. Otherwise what will happen, only the cost will get swapped. So if we execute this now, and let's just print this thing. So print the book value, book list. So this should now work fine. So first of all DLD, then DLD, CG, DSA, DSA, DM and OOP. So here this duplicate list was commented, so we are getting the duplicate list. But now if we delete these things, so now we will get the required answer. So first of all we remove the duplicate and we got a unique list, and then we arrange these things in the ascending order. So first of all DLD 300, then 400, then DSA 500, DM 590 and OOP 700. So this is the basic arrangement of the books in the ascending order. Similarly, if you have to do the same in the descending order, you can only change this comparison operator, and this should give the same output. So 700, 590, 500, 400, 300. So this should work fine, but we need now in ascending order, so we'll keep this. So let's just execute again, and now we can see we are getting the arranged ascending order list. So this same thing which is in which we are arranging the books or arranging any elements, this is called as sorting. So we are sorting ascendingly the elements depending on the cost of the book. So there are various algorithms to sort a list of data, and the thing we just saw is the selection sort algorithm for sorting the list. So here we basically check for the minimum element and put it at the first position. Then similarly we do for the remaining list, and like this we get a sorted list. So we'll learn more about this in our future lectures when we will discuss the main concept of sorting, searching and various things. But for now you should have got a simple idea how this sorting works. So now as we have arranged the books in the ascending order depending on the cost of the book, now we have to count number of books which cost more than 500. So what we can do is we can simply use the for loop. So define count book greater than, we can use a count book filter and then take an input. So cost, what would be the cost above which we have to count. So for default value I will put as 500, and if, so for instead of if, we have to loop through each element. So instead before looping we have to create a counter variable. So let's just take cnt equal to 0. So this should be a counter variable. For then I can use a for loop for book in book list. What I can do is, if book of 1 means I'm basically accessing the cost directly using the book. So book of 1 means the cost, the book cost. If book cost is greater than the cost given here, so if it is greater than or equal to, so there may be a equal book also, we have to increment the counter. So we have to add 1 to the counter. So this is same as this thing. So cnt equal to cnt plus 1. Just I have used the assignment operator and done the thing. So increment the thing, and at last we can return the counter. So I can print. So what I can do is I can print the count. Instead of printing count, I can use the count book filter. So let's just use this parenthesis and execute. So at last I am getting 3. Why 3? Because DSA, 590, DM and OOP. These are the 3 books. Similarly, the fourth function says that we have to copy the books in the new list which has cost less than 500. So we can again use the same thing. Let's just create one more function. So define separate underscore book underscore filter. So why am I using this parameter? So let's just assume for this case they have mentioned that the cost should be 500, more than 500, but there may be a case where this value may change. Let's just take this as 300. So what would happen? We can directly change this input. So defaultly it would be 500, but now if we have to filter this according to some value, I can directly provide this value in this function and it should return me the count. So this is count 5. Why? Because 300, 400, 500 and this all elements. So similarly, if I put here 400, then I would get 4 elements. So this becomes a flexible code and you can directly change these values. But the default would be 500 because in the question it is mentioned that. Similarly, here also I will take a cost and then cost equal to 500. Similarly, the default value. And for first of all, I have to create a list. So less underscore cost underscore book. So this should be an empty list. For book in book underscore list. So I will go to each book. If the book cost means the book of 1 is less than, if it is less than the cost, then what I will do, I will add that book to the least cost book. So less cost underscore book dot append. So I will append the current book because it is less than the cost, and then at last I will return this less underscore cost underscore book. So let's just try to print this. So print separate, or we can directly copy this function name and execute this. So here we can see these 2 books are less than 500. So we have created a separate list. So I can also put some strings. So define which question we have just solved. Here we are using this C. Here we are using the B question, means we are solving the B. And similarly here we are using the A, means deleting the duplicates. So A dot, and let's just execute. So here A, B, C, D. So this works fine. And we can also uncomment this and create a docstring so that we can directly print. So 3, and here also 3 quotes. So now to print this above everything, what I can do is I can directly print here only. So print underscore underscore doc underscore underscore, and this should print the question. And after that, let's just give a new line directly. So a new line and then the answer for each of the case. So this was the basic function working for each of the cases mentioned in this question. So here, as we have discussed the approach using the tuple, similarly let's just see how we can use this same thing using the classes. So class book, and then let's just give an init function. So init, then the compulsory self parameter, it would take a name and the cost of the book. So then what we can give is self dot name equal to the name, and self dot cost equal to cost. So I'm just assuming that you have an idea about the classes. So if you don't have any idea about this classes and object, you can check out a video about the OOP, object oriented programming, or let me just explain the basic. So we can create multiple objects using a similar structure, as the architecture creates a design for the building, and similarly that building can be created using various things. Similarly here also we are defining a structure for the class book. So means class is used for creating a structure. So we are creating a structure for the book and saying it would have two properties. So it would have a name and a cost. And then to take these properties, we have an init function. This is a magic function given by the Python. Whenever an object, means a real entity of this structure, is created, it would take these two parameters, name and cost, and create an object of that. Means that object would have two parameters, the name and a cost, similar to this as we have in this tuple. So it would have two parameters, two properties. First of all name, and second is the cost. So this would be a basic structure for the class. And then what we can do is here can use book and give the name comma cost, and this should create a book. Now we can append this book, and let's just check the print list. So the other all things would give an error. So let's just comment these things out and execute. So here we can see the these are the objects. So here we can't directly see the values. So to see the values, what we have to do, we have to use a for loop. So what you can do is for I in book underscore list. So here instead of I we can use the book. So book, and then to access the properties I can directly use book dot name and then comma book dot cost. So if I use this, I can see directly the DSA and 500, CG 400, DLD 300, and similarly. So here for the delete duplicates, there will be a slight change. What will happen here is whenever we check if book is in the unique book list, it will check the values. Directly it will check for the places whether both the elements are same or not. So for example, if we have 3 and 3, then it will check whether 3 and 3 are same or not, and then it will return. But while we are creating an object, this object are stored at different address places, so different address locations, which we can see here. Let's just print directly the book list. So if I execute this, here you can see main underscore underscore main underscore underscore dot object at some address. So here some address, each book has an unique address. So here we can't directly check two books. Why? Because it will check the addresses, and if addresses are different, then it will say that these are not the similar books. So for that we have to use a for loop. So what we can do is for book in unique underscore book list. So we have to check the unique book list. So as we are checking for the each element in the unique book list, we will, let's just take book u underscore book, so that we get so that we have an idea that which book we are checking. So for each book what we can do is if u underscore book dot name equal to the book dot name. So here this book, the plain book, refers to the main parent which is coming from the book list, and ubook is an unique book which is added to the unique book list. So we can check the name and we can check for the cost. So u underscore book dot cost equal to book dot cost. So if this both are same, means we have an similar copy. Means what we can do is copy, or we can create does copy exist a variable. We will set this to true, and at first we will create the same variable and set this to false. So why do we need this variable? Because we have to check for each of the element. So there may be multiple elements, so for that we can use this thing. So instead of true, capital true, and this should be false. So then what we can do is, if does copy exist, so similar to the previous function, if this is not, means copy does not exist, then we have to add. So we can use unique, we can directly copy this name. So we will append this book. So this should return the thing, and let's just uncomment this and check whether it works fine or not. So this will return a book list. So instead of book list, what we can do is can again use the same for loop, and we will remove this thing. So we don't need the indexes. So we'll print a, and then we will print the for loop. So here now we can see the copies are now gone. So here DSA had a copy and it is not present here. Similarly other things also. So before a, let's just put a new line so that to separate out things. And yeah, so similarly now for arranging the books, here we have to again do some minute changes. Instead of book list min value index 1, what we have to do is book list min value index dot cost. So here bracket 1 was the cost, so we can directly change this to property as dot cost, and here the things would swap. So other thing would work fine, just we are based on the cost. So let's just execute this, and instead of book list, let's just print the things. So we would need this for loop to print each element from the book list. So here we can see at first they were not arranged, or we can also call it not sorted, but now 300, 400, 500, 590 and 700. Similarly here also for the count book filter, instead of using the book of 1, I can directly use book dot cost. So this is more readable as we are using object oriented programming, but yeah, so this should work fine because we are printing the cost directly. We are printing the count, so it wouldn't affect. And similarly separate book, and here, so we have to loop through this list in this separate count list. So what we can do is we can use this for loop again and paste this thing here. So instead of book list, we have to loop through the returned value from this separate book filter. So this will return a list and we have to loop through that. So if I execute this, so book, okay, here also book 1 is less than cost. Instead of book of 1, we have to use book of cost, book dot cost. So here also we are getting DLD 300 and CG 400. So these are the minute changes which we have to do if we use the class thing. So that's the only change, and yeah, that's all for this video. We have seen both the methods by which we can solve this question using the object oriented and without using that. So this would be all for this video. Let's just meet with the new question in our next video.